This is section 4.1 on maximum and minimum values. And so on page 276, take a look there, grab myself a pen. All right, so we have graphs like this. Okay, this is considered a maximum point. There's a minimum point. Okay, so we have an absolute maximum and an absolute minimum. There's a very formal definition. I'm not going to hold you to it. It's kind of obvious. Absolute maximum is absolutely the highest point in the graph, and absolute minimum is absolutely the lowest point in the graph. You're allowed to have ties. You can have ties for maximum and minimum. Okay, figure 2 here. Okay. This is an absolute minimum, absolute maximum. Okay. You can have local max and min or relative maximum and minimum. Okay. So this would be a local or relative minimum, relative maximum, relative minimum, relative maximum. So relatively speaking, if you take a small neighborhood of the point, it's the highest or lowest, but not for the entire graph. Okay. Local minimum, local maximum, local and absolute minimum in this particular case. Okay. And if you're at an absolute maximum minimum, you're automatically at a local or relative maximum minimum. Okay, that's a guaranteed already. Okay, so my abbreviation for local is LOC or REL for relative. And for absolute, we'll say ABS, absolute max or min. Okay. Okay, this looks like a cosine function. Okay, so you have ties for absolute and local maximum all happening at y equals 1, and a tie for local and absolute minimum at -1, right? Y equals x squared, absolute minimum at the origin, there's no maximum, just goes up, up, up. Okay, y equals x cubed has neither a maximum nor a minimum, so there are no minimum, no maximum. Okay, here's a graph of a function. Okay, absolute maximum, relative maximum, relative maximum, relative minimum, absolute minimum, and relative minimum. Okay, so one thing you want to notice about the maximum minimum points, what seems to be the slope right here, and here, and here, 0. That's not true here or here, but these happen to be endpoints. Okay, so we'll keep that in mind. It looks like to have a maximum minimum, the derivative is either 0, if it's defined at all, or maybe it's an endpoint. All right, page 278, extreme value theorem. Puts us on your formula sheet if you wish. If f is continuous on a closed interval a to b, f attains an absolute maximum, f of c, and an absolute minimum, f of d, at some number c and d between a and b. Okay, so if you have a continuous function, somewhere there's an absolute max and an absolute min. Absolute max, absolute min. Absolute max looks like it's a tie, absolute min. Okay, for closed interval, that always has to exist for continuous functions. Okay, Fermat's theorem, page 279, what we were just talking about. If f has a local maximum or minimum at c and the derivative exists, then it has to be 0. Okay, so we saw that in this picture over here somewhere, right? If you have a maximum or a minimum, if the derivative exists here, here, and here, then that derivative has to be 0. If the derivative does not have to exist, you might have a corner point, like this point over here. It's a minimum, but the derivative is not 0, but it doesn't exist. Okay, that looks like a relative maximum. Derivative is 0, derivative is 0, derivative is 0. So derivative is 0, or maybe undefined, max or min. And we have given a name to that. Critical number. A critical number of a function is a number c in the domain of f, such that either f prime of c is 0 or f prime of c does not exist. Now, when we start doing problems, most of the time we're going to say f prime equals 0. Only once in a while will the derivative not exist, but the c is in the domain of the function. Okay, what's so good about having this? This will give us potential maximum and minimum points for our graph. Right, and closed interval method to find the absolute max and min on a closed interval. It's on page 281. You can put that in your formula sheet. But this will pertain to problems starting with what? It's 47. 47 through what? 61. Okay. You're trying to find absolute max and min of a continuous function on a closed interval. Okay. So here's the algorithm. Find the values of f at the critical numbers. That means set the derivative equal to 0. And when is the derivative undefined? But the function is still defined. And then find the values of the function at the endpoints, because the maximum minimum might be there. The largest of these values is the absolute maximum. The smallest of these values is the absolute minimum. Okay, so let's get started. Some of the problems here. Okay, so page 283. And we have to go up to problem 61, it looks like, on our homework sheet. Yeah, 3 to 43 odd, 47 to 61 odd. Okay, so here we go. For the benefit of those of you that don't have the book and aren't getting it. So I kind of have to raise it up funny in order to show it because the book is right up against the document camera here. I think you can read 11, even though it looks weird. Okay, 13, 15 through 24-ish, 25, 27, and some more problems at the end. Let's see if I can maybe go like this. Maybe that's a little bit better. 29 through 35, I hope you can read that. Yeah, I can't straighten it out any because my book is hitting the document camera already. Bring this back down a little bit. 47 to 43. 47 up to about 55-ish. And it's up to 61. Okay. All right, let's take a look at the pictures. So each of the numbers A, B, C, D, R, S state whether the function has an absolute max or min, local maximum, or neither. Okay, so focus this. So A looks like a local max, local min, local max, that looks like nothing, local min and absolute min, local max and absolute max. And so that's all. Okay. 5, absolute and local maximum minimum values of the function. Okay, so local minimum at 0, 2, local minimum at 1, 3. So I go either to the left or the right. We're only looking up, in this case, quite a bit up. That's okay. 2, 2, local minimum. Let's see, 1, 2, 3, 4, 5, 1, 2, 3, 5, 5, local and absolute max. 1, 2, 3, 4, whoops, 1, 2, 3, 1, 2, 3, 4, 1, 2, take it back, that was 4, 5. This is 5, no, I'll get it right. 1, 2, 3, 2, 3, 4, 1, 2, 3, right, 4, 5, absolute max, local max. And what was this? 2, 3, 4, 5, 1, 2, 3, 5, 3, local min. Local max, wherever this is, 2, 3, 4, 5, 6, 1, 2, 3, 4. And that's nothing, and that's nothing. Okay. All right, some graphs. Number 7. Absolute max at 5, absolute min at 2, local max at 3, local min at 2 and 4. I can't really show you both at the same time. I don't have them in my hands. But here's the essence of it. Continuous, 1 to 5, absolute max at 5, absolute min at 2, local max at 3, local min at 2 and 4. So something like this. Notice I didn't even put the y coordinates. So how high is it? We don't know. This is the relative position though. Okay, 11. Sorry, can't quite get this here. 11, sketch the graph of a function that has a local max at 2 and is differentiable. And B, continuous but not differentiable at 2. Okay, so that'd be something like a corner point. Right, so A, max at 2, differentiable. So that means the derivative has to be 0, right, for max term. Maximum 2, not differentiable, so maybe a corner point, like that. (13) Sketch a graph of a function on -1, 2 that has an absolute maximum, but no absolute minimum. Okay. Absolute maximum. Oops. Absolute maximum. No absolute minimum. So this drops down to infinity. And then I kind of go something like this. So this is not a continuous function. Okay. All right, then we have some sketches and also find the critical numbers. Okay, let me show you 29. Critical numbers means derivative is either 0 or undefined. Okay, so I take the derivative and set it equal to 0. The derivative of this is 1/3 minus x. Okay, when is this undefined? Never. So x equals 1/3 is a critical number. Okay, that's all for that one. All right, some of these graphs. 15, y equals 1/2 3x minus 1. X is less than or equal to 3. So I plugged in 3, I got 4. I know it's linear, so it goes something like this. So absolute max and relative max at 3, 4. 21, sine function from negative pi over 2 to pi over 2 looks like this. Negative pi over 2, -1, pi over 2, 1. So absolute max and a relative max at pi over 2, 1. Absolute min and local min at negative pi over 2, -1. Okay. 25, y equals 1 minus radical x. Looks something like this. Plug in 0, you get 1. Plug in 1, you get 0, and it drops. So an absolute and relative max at 0, 1, and it just shoots down forever. So there's no minimum. Okay, find the critical numbers. 33. Take the derivative, set it equal to 0. So the derivative is 4t cubed plus 3t squared plus 2t equals 0. Factor out a t. That means t equals 0. Or I set this equal to 0, but this thing can never be 0. If I use the quadratic formula, I get a square root of a negative. So t equals 0 is my only critical number in this particular problem. Okay, 39 is kind of interesting. F of x is x to the 4/5 times x minus 4 squared. So let me show you that one. So product root, f prime of x is first times root of the second times 1, chain root, plus second times root of the first, 4/5 x to the -1/5. Clean it up, 2x to the 4/5 times x minus 4 plus 4 over 5. X to the -1/5 means x to the 1/5 on the bottom, x minus 4 squared. Okay, so x equals 0 is automatically a critical number because plugging in 0 will give me an undefined derivative, but 0 is allowed in the original problem. Okay, so x equals 0 is a critical number because the derivative is undefined. Okay, now I set this mess equal to 0. So you multiply both sides by 5x to the 1/5, which makes it look nicer. Okay, 5 times 2 is 10. X to the 1/5 times x to the 4/5 is x to the 5/5, or x to the 1. X minus 4 plus 4 times x minus 4 squared. Factor out an x minus 4. I'm left with 10x plus 4 times x minus 4. This turns out to be x minus 4, 14, x minus 16. So critical numbers, we already said was 0. What makes this 0 is 4. What makes this 0 is 16/14 or 8/7. So I have 3 critical numbers. Okay, 47. Find the absolute max and min on the given interval between 0 and 5. So I'm for sure going to plug in 0 and 5, and I also plug in any critical numbers. So I get a list. The highest y value of that list is maximum. The lowest y value is minimum. All right, so the derivative is 4 minus 2x. Set that equal to 0, x equals 2. So I plug in 0, 5, and 2. F of 0, 12 plus 0 minus 0, 0, 12. f of 2, 12 plus 8 minus 4, 16. Plug in 5, 12 plus 20 minus 25, 7. Okay, so I check the function value at the critical numbers, and I also check the function value at the endpoints. So here, here, and here. What's the smallest y value? 7. What's the largest y value? 16. So absolute max at 216, absolute min at 5.7. Here's another one, 53. f of x equals x plus 1 over x at 0.2 comma 4. So for sure, I'm going to plug in 0.2, and for sure, I'm going to plug in 4. Okay, this is x plus x to negative 1. F prime is 1 minus x to negative 2, which is 1 minus 1 over x squared. Set it equal to 0. Multiply both sides by x squared. X squared minus 1 equals 0. X plus 1, x minus 1 is 0. That means x is negative 1 or 1. Negative 1 is not under consideration, so I plug in 1. Okay, so I plug in the two endpoints, f of 0.2, 0.2 plus 1 over 0.2, 5.2. I plug in the critical number 1, I get 1 plus 1 over 1, 2. Plug in 4, well, 4 plus 1/4, 4 1/4. Okay, so I got that one, that one, that one. What's the absolute max? At 5.2, so 0.2 comma 5.2. Absolute min is this one, 1 comma 2. Okay. All right. That's it for that one. Let me try for you what? 37. Finding critical numbers, h of t is t to the 3/4 minus 2t to the 1/4. So take the derivative. Here it is. 3 over 4t to the 1/4 minus 1 over 2t to the 3/4. Set it equal to 0. Okay. I don't like all the fractions. And by the way, that makes t equals 0, a critical number, right? You can't plug in 0 here, but you can plug in 0 here. Now, to clean it up, I'll multiply both sides by 4t to the 3/4. That cleans up the denominator here and the denominator here. That gives me 4's cancel out. 3t to the 1/2 minus 2 equals 0. Add 2. 3 radical t is 2. Divide by 3 and square. T is 4/9. So my critical numbers are 0 and 4/9. 41. Find the critical numbers. So f prime is negative 2 sine theta plus 2 sine theta cosine theta equals 0. Factor out the 2 sine theta. Negative 1 plus cosine theta is 0. That means either sine of theta is 0 or cosine of theta is 1. Sine of theta is 0. That's here, 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 here. So k pi. Cosine theta is 1 only here, but this is already swelling up with this. So I can just say theta is k times pi, where k is an integer. Okay, 43, find critical numbers. Product group. First times root of the second, e to negative 3x times negative 3, chain root, plus the second times root of the first, set it equal to 0. Factor out x, e to negative 3x, and what's left behind is negative 3x plus 2 equals 0. So that cannot equal 0. X is 0, and this one will give me x is 2/3. So my critical numbers are 0 and 2/3. Okay, 57. 2 cosine t plus sine of 2t from 0 to pi over 2. Find absolute max and min. At first, I rewrote this sine of 2t as 2 sine t cosine t. It's a little bit cleaner. So now I differentiate. Differentiate means take a derivative. Negative 2 sine t plus product group. First times the derivative of the second plus second times the derivative of the first. Set it equal to 0. Negative 2 sine t minus 2 sine squared t plus 2 cosine squared t equals 0. Okay, change everything so there's only one trig function. So I changed this cosine squared to 1 minus sine squared. Clean it up. 2 sine t minus 2 sine squared t plus 2 minus 2 sine squared t equals 0. That's negative 4 sine squared t minus 2 sine t plus 2 equals 0. Factor out a negative 2. Factor further, negative 2 times 2 sine t minus 1 sine t plus 1 equals 0. That means sine of t is a half. Y coordinate is a half. Or sine of t is negative 1. That's the south pole way down here. Okay, so I have pi over 6. And let's see, we only want stuff between 0 and pi over 2. So pi over 6. And here sine of t is -1. That's not going to be something between 0 and pi over 2. So my only critical number is pi over 6. Okay, so I plug in 0 to the original. Put 0 here, that's 0. 2 times cosine of 0, 2 times 0 is 2. Cosine of 1. Cosine of 0 is 1. 1 times 2 is 2 is what I meant to say. F of pi over 2 is 0. Let's see. Pi over 2, cosine is 0. Plug in pi over 2, I'm taking the sine of pi, which is also 0, right? And then my critical number, pi over 6. So 2 cosine pi over 6 plus sine of pi over 3. Radical 3 over 2. Another radical 3 over 2. 3 radical 3 over 2, which is bigger than 2. All right, so absolute min, pi over 2, 0. Absolute max, pi over 3, comma, 3 radical 3 over 2. All right, so that is section 1, section 4.1.